Okay, so for today, the solving radical equations, and these will be level 1 in difficulty. So first we're going to get the square root or the cube root by itself, use a square or a cube to undo the radical. We're going to solve the equation for x, and then we're going to plug that x in and check for extraneous solutions. An extraneous solution is an apparent solution that does not work, does not check in the original problem. All right, so here we go. We want to get the radical by itself. And in that first problem, it already is. The square root is the only thing on the left side of the equal sign. So we will go straight to using a power, square in this case, to cancel out that square root. A square and a square root are opposites, so they cancel out. So we have 5x plus 2 equals to 10 squared, which is 10 times 10, so 100. And now we're to step 3, where we're just going to solve for x. So we're going to subtract 2, which gives us 5x equals 98. And then we'll divide by 5, so x will be 19.6. Okay, that leaves us to the check for extraneous solutions part. If we're going to check, we need to place 19.6 in for x in the original math problem before we squared both sides. So we're going to have square root 5 times 19.6 plus 2, all in the square root. And we're going to make sure it equals 10. How we're going to do this is in our calculator. But in order to use a calculator, especially a Casio, we have to use parentheses around what we're typing. Otherwise, it would just take the square root of the 5, because that's the first number. But you wanted to take the square root of the 5 times the 19.6 plus 2. So you put that math problem in parentheses. Okay, so I'm going to enter this side of the equation into my calculator, hit equals, and I'm going to find out that 10 equals 10. And so I know that it is true, and 19.6 is my answer. Okay, I know it's small there, but I've inserted a screenshot of my calculator so you can see sort of how that looks. All right, next example. On this cube example beside us, the square root, or the cube root rather, is not by itself. It has this 3 in front. So that 3 is a multiplied value, so we're going to have to start by dividing. So we're going to have 10 equals the cube root of x plus 9. Step 2, we're going to use a power to undo the radical. Since it's a cube root, we're going to cube both sides. So 10 times 10 times 10, 10 to the third is 1,000. Cube root and cube cancel each other off, so that equals x plus 9. And so solving is just to subtract 9. So 991 equals x. Again, I have to perform the check to know that that for sure works out. So I need to know if 30 really equals 3 times the cube root of 991 plus 9. Anything inside the cube root needs to be in parentheses. Okay, I have a more visible picture this time of my calculator showing you that if we enter it, including the parentheses, it does in fact equal 30. So our answer is in fact 991. Moving on. Okay, neither of these are dramatically different. Just remembering that you want the square root by itself. So in this first problem, we begin by adding 10. So 2 equals the square root of x plus 6. And now that the square root is alone, we'll square to get rid of it. So 4 equals x plus 6. And we subtract 6, so we get negative 2 equals x. Again, we're not done until we check. So we want to see, does negative 8 equal the square root of, remember inside the square root has to be in parentheses in your calculator, negative 2 plus 6, square root stops at the parentheses stops the square root, and then we do subtract 10. So using the parentheses in my calculator, as you can see, negative 8 equals negative 8, so that checks. Okay. Sometimes the steps are combined, like in our next example. We have to do more than one thing to get the square root by itself to get started. In this problem, we first need to add 10. So 26 equals 2 times the square root of 2x plus 3. Next, we have to divide by 2. We're still not ready to square both sides. So 13 equals square root of 2x plus 3. Then we're finally ready to square both sides because the square root is finally alone. 13 times 13 is 169. Square root and square cross off, so 2x plus 3 is left. And we're ready to solve by working backwards. So subtract 3, 166 equals 2x. Divide by 2, so 83 equals x. But of course we're not sure until we do the check. So we have to check out 16 equals 2 times the square root of 2 times 83 plus 3, all in parentheses, and then subtract 10 after the parentheses. So sure enough, 16 equals 16. So we have a correct solution. Okay, one last time. Let's change the form. Okay, hopefully you will notice that you know this already. This is the same work. It is just changed to function notation to keep that in our review. Remember, if you have a number in the parentheses, that's your x. So we need to plug in x. Or you may remember that you're allowed to use your graphing calculator and trace. If you're plugging in x, remember to use parentheses. You'll have 18 minus negative 2 in parentheses, and then add 7. When I enter that into my calculator, how I have it written, I get 11.472. Okay. For the problem down here where it says find x when f of x equals negative 12, that's of course when we make f of x equals 12. So 12 equals the square root of 18, subtract x, add 7. That's the same work that we have been doing. Get the square root by itself, so subtract 7. 5 equals the square root of 18, subtract x. Square both sides to remove the square root. So 25 equals 18, subtract x. Subtract 18. So 7 equals negative x. And divide by negative 1. So negative 7 equals x. And even in this type, please remember to check. Does 12 equal the square root of, in parentheses, 18, subtract negative 7, and then add 7 after the parentheses. And as you can see, yes, it equals 12. So 12 equals 12, and that checks. So x equals negative 7 was the value that worked. If you have any follow-up questions, please ask them in class.